Hello again. Hello everyone. Guys, thank you very much for attend at this last session of training from us, and welcome to the RCF professional team members. So I'm very pleasure for that. And hello Panagiotis. Thank you again. For your effort to organize these events. Is very important for us to spread knowledge, to spread information about our last technology and so on. You know what? You know that this is really important for us. And so, hello. And so today we are going to do more or less the thing that you see in the list. So we are going to work directly with RDNet in order to see what is the RDNet workflow. Starting from the design of a system, and then after the design, we can move the data to the is-focus prediction software. That is a prediction software that we usually use to make a software simulation of a system in a certain venue in order to demonstrate at the client what is the behavior of the system before set up the system. And it's really good because the result of his focus are really close to the result, to the real result with the real system once set up. And then I will show you what is our way to create a technical document to demonstrate the system capability in a certain situation. Okay, very easy. So we use a couple of tools to do that, and I will show this. So, but without losing time, let's go to open RDNet. Let's move out from PowerPoint, and then maybe we will need to come back here to see some slide about some theory about time alignment. But for now, let's go out and let me open RDNet. So the first time that you run the software, you must enter your username and your password. These are username and password of your RCF free account. So if you still do not have an RCF account, register in order to have the possibility to log in RDNet. So my user account is my mail, my password. Verify, and as soon as, sorry, there is a problem. Sorry, maybe about IT. I'm not able to log in. Wait a moment. Okay, sorry. The caps lock of my keyboards was turned on, so I invert the uppercase with lowercase, and so the password was wrong. Anyway, as soon as you input your username and password, you are in the software. So this is an empty workspace. Okay. So the first thing that we have to do when we have to go to design to set up a system is to design the system. Okay. So you can see we have a toolbar menu with the menu file where we can save and load our synoptic design. The menu view with some tools to arrange the icons once the icons will be on the workspace. Menu tools where we have some functionality, as we will see, measurement, cloud, venue that we are going to use, and other function. Option with some full screen option, background image, different skin for the software interface, the setting of the software, and advanced menu where we can update the firmware of the devices. We can turn on and off the display on board of the speakers, because sometimes in some indoor venue, for example, the lighting of the speakers can be not suitable, so you can turn off the light of the LED of the speakers. Bypass override, reset angles, because you remember I told that inside each box there is an inclinometer, so we can reset the inclinometer. Password for the concert and the sound check mode. Now we are going to work in sound check mode where every function is open. In concert mode, some functions are not available to avoid, for example, to mute the system during the show. Okay, but of course, in 1 hour, it is not enough 1 hour to talk about everything in RDNet. Okay, so this is the workflow. This is the basic workflow. And then, of course, there are a lot of video tutorials talking about in deep, talking about every single topics. And also, as I told in the last session, I hope to have the possibility to come soon in Greece in order to do a full day of training with a real system flow, in order to have the possibility to listen during the training, to go on the stage, to see how behave a cardioid's configuration of subs, etc., etc. Anyway, let's go in the menu tools and go to the menu venue in order to create a new venue. A window will open, and let's click on new, and this is the tool that we need to design our system. So let's suppose to work with an HDL30 system. So select the kind of system, HDL30, with 8 modules per side. Okay. This is our audience area where we want to start with the coverage. Let's suppose to start at 6 meters, and the end coverage, let's suppose that it can be 60 meters. We now click on create, and then we have to set the height of the system, the height of the flybar. So let's suppose that we can fly the system at 8 meters. Okay. So be sure to insert the temperature and the humidity value. So today here, let's suppose to work here today, we have 50 degrees with 70% of humidity, because it's raining in this moment. And that's all. This is everything we need to design the system. Click on Autosplay and the work is done. As you can see, automatically the software will create a rough, let's say, view of the cluster with the aiming of each module. Okay. And the pickup, mechanical pickup data, so pickup point and direction of the shackle. We have some physics information about the clusters, the weight of the cluster, the pickup point. Again, in this case, we are working with one pickup, so the front pickup load and the rear pickup load at 0. Instead, if we move to 2 pickup point here, according with the tilting of the flybar, there will be the weight in the 2 different points. And the last speaker distance from the ground. Okay? The work is done talking about design. So we can double click in the name of the venue and let's call this venue, I don't know, Lucio Theater. Lucio, no, let's call the venue HDL30. It is much better. Okay, HDL30. Now, I am working offline. So I can come back to my workspace that is still empty. As you can see from here, I can move in my design, or I can come back in my workspace, which is empty in this moment. From my design, there is the possibility to print this view where all the data are printed or saved as PDF in order to go to the venue and having all the documentation to set up the system, angles, as you can see, etc., etc. This is really important, the presets that will be automatically applied at the cluster. Okay, so let's come back to the workspace, and from the menu tools, we can add manually the object. I have to add manually the object because the objects are not here in this moment. I am working offline. Later on, we will go online with one system, taking some measurement, because I have a small system outdoor to demonstrate how is the workflow usually, scanning directly a real system when the system is flown and connected. But in this moment, I want to demonstrate the system that we have just designed. Okay, so let's here we can see some the product divided by categories. Otherwise, you can scroll these windows until you find the device you are looking for. In this case, HDL30. Okay, so let's drag and drop in the workspace. As you release the mouse, you can select the number of boxes. So let's suppose 8 boxes. Our cluster is made by 8 boxes. And then the address of these clusters. This cluster will be connected via network, via Cat5 cable, to the controller 1, let's suppose to work with a control 8, line 1, okay? Add, and as you can see, we have 8 modules of HDL30 in our synoptic design. This red button means that the device is not present because we are working offline. But in order to demonstrate the RDNet workflow, it is more than enough to work offline because all the elements are there. Okay, but we need the right cluster. So drag again on the workspace the icon of the HDL30. We have 8 boxes, and but at this moment the boxes will be connected at the line 2 of the control 8. It's more convenient to use another line instead of make a round with the network cable, because we could use just one line, because in each line we can connect up to 32 devices, but it is not convenient. It is better to go with output 1 to the cluster left, output 2 to the cluster right, output 3, network output 3 on the sub, for example, and network output 4 to the front field. And then delay, side field, depend on your system layout. Okay, add. And here we have the right cluster. Okay, left and right. At this point, we need to add a subwoofer. So let's suppose to work with subs 9006 AS. Let's find out where it is here. Drag and drop. Okay. So we will work with 8 subs that will be connected in the line 3 of our control 8. Add, and here we are with the subs. But these subs, what will be the arrangement of these subs? I would like to place these subs in a row, okay, in order to have a straight line of subs. So I want to see my synoptic design as my system is in the real life. So go to View and select the subs. Sorry. Hello, Vangelis. Good to see you. Hi. Hi, everyone. And so select the subs and then align in a row from the menu view. And this is my layout of subs. Okay. So let's zoom out with the mouse wheel and drag the subs in their position, as well as the cluster left and the cluster right. Okay, so this is my system. Very easy. Okay, now what is the second step? Okay, I am working offline. So the second step is to say to RDNet that we are working in according with this design. Okay, the design that we just did a couple of minutes ago, 5 minutes ago. HDL20 with these angles, with this preset, with this condition of temperature and humidity. So how to tell at the boxes that we want to work in this with these let's say features, with these presets? It's very easy. So let's come back to our design. Select both the cluster, supposing that left and right are equal. Now we can close the windows to add object, because we don't need to add object anymore. Zoom out. So select the cluster, and then first of all we have to assign these clusters to a group, to an array group, okay, because they are line arrays. Right click in some place. Once both the cluster are selected, we can right click and then assign to array. Okay, let's assign to array 1, keeping just one zone for now, but I don't want to talk about zoning today, because this is an advanced way that is really not necessary in all the situations. If you are working outdoor, probably you don't need to make more than one zone in your cluster. So as you can see now, the clusters changed the color, meaning that the modules are grouped together. In fact, if I go and if I mute one box, you can see that all the boxes are going in mute. Okay? Almost done. Right click again and connect to venue. The venue is the HDL30, is our design, HDL30. So right click and connect to HDL30. In this moment, just coming back to the venue and click preset apply, the work is finished. Okay, talking about cluster. Because as you can see, we can zoom, we have the HF preset applied, different for each box. And if I go in the detail menu of every single boxes, let me come back here. Okay, open the EQ, clicking on the EQ button of any icons, because we are talking about a group. So clicking in the EQ button of any icons will be exactly the same things. And the equalizer will open. Not just the equalizer, the internal DSP of our clusters. As you can see, we have the pink line, which is the line coming from our design. So with this correction about high frequencies and no correction about low frequencies. Because in our way to think about line array system, we think that clusters made by 8 modules is a standard cluster. So we start from here thinking to a flat low frequencies level. If we work with less boxes, we have to increase the cluster size. If we work with more boxes, we have to decrease the cluster size, the amount of low frequencies. Okay? And the best shaper is the tool to do that. But in this case, we don't need to make any adjustment in the best shaper. So let's go back in our equalizer. We have the gain and we have the delay if we want to move the system backward. And also the phase, the polarity. Let's look at this, okay? Look at the high frequency correction. If I change the humidity level, going, for example, at 50%, and clicking on preset apply, can you see that this change a lot? And also, if I open the properties of the selected object, you can see the properties of the first box. The preset is number 9. The last box is number 1. Then 8, 5, 4, 3, 2, 1, and 1. And this is the preset of the low frequency, which is flat. We can manually change this preset, but as a starting point, it is convenient to work with the suggested preset, okay? In this moment, the clusters are tuned. The clusters are ready to play. So without doing a webinar, without explaining how to work with RDNet, if I was on the field, this job will take less than 1 minute. Less than 1 minute, okay? In less than 1 minute, we tune differently a cluster box by box with different preset box by box. This is something impossible to achieve in a standard way to tune a system. For example, with several feeds with an external processor. Impossible in this time. Okay, so let's come back in the properties of our cluster. Now the second thing that we have to set is the crossover. Okay, here there is the high pass filter. We have to set the crossover according with our thought, according with our subwoofer. So in this case, I will crossover my system at 60 Hz. Okay, so let's type 60, and in real time, the boxes will be crossovered at 60 Hz. At this point, if I need to make some adjustment, talking about equalization, for example, my system is a little bit boxy, something like that. So I can enable one band of my equalizer, for example, and I can reduce the box's frequencies, for example, at 750 Hz by a couple of dB, if it is needed. But I am doing something without sense in this moment, just to give you an idea. Okay, if I am working indoor, for example, it is probably I will need to reduce a little bit the frequency around 100 Hz that sometimes make some noise in the low frequency because of the reflection indoors. So let's reduce by 4 dB. This is something that happens commonly, but nothing else. Okay, because the systems, if the system is well designed. Okay, if the system is well designed, you don't need to work too much with the equalization and custom settings. Okay, what does it mean a system well designed? Let me come back to my venue view where I can see the design. Okay, let's suppose to work with the same cluster, okay, but my pickup point is not at 8 meters, it is 10 meters, and I don't want to start at 6 meters, but I want to start at 3 meters, my coverage. So my cluster is at 10 meters, and I want to start at 3 meters, my coverage, until 60. Let's see what happened with autosplay. Okay, you can see this cluster. This is not a cluster. This is something more similar to a banana. Okay, very, very, very curved. We have a total curving of 55 degrees minus 7. So we have a global curving of 48 degrees. Definitely too much. We are losing all the coupling between the boxes, and of course the boxes can sound, but I'm sure that the boxes will not sound good. Okay, conversely, if I go back to with the system and I want to start with my coverage at 10 meters and the system is flown and at 5 meters autosplay, you can see that the system is almost straight. Look at the degrees. This is a straight line. And in this case, the system will become completely aggressive, very harsh, because of the coupling between the modules. Okay? So our indication is that we have to work with a common curvature of the cluster, and a common curvature is, coming back to the data we had before, a common curvature is a curvature where we can find a global amount of degrees around in between 20-25 degrees. This is a common curvature. With this curvature, I am sure that just with the preset coming from the shape designer, the system will sound good. Okay? So you can see we have the last boxes at minus 29 degrees and the first one minus 5. So 29 minus 5 is 24. We are in between 20 and 25. This is the right curvature of the cluster. Okay, let's go back. If the cluster were connected, this setting will be automatically in real time sent to the system. Now the subs. With the subs, we are working with a straight line. Okay, so do you remember in the webinar yesterday that in the sub 808 simulation, we see that the subs in a straight line tend to concentrate the energy in the center. So we have to create an arc of subs in order to spread the energy in a constant, in order to have a constant coverage in terms of frequency response in the low frequencies. Sorry, I forget. Before do that, we have to select the subs and select the proper preset. As soon as I select one box or one series of box, in this case I select all the subs, I can from here select my preset. In this case, if I am not wrong, our crossover was at 60 Hz, so let's select the preset S2 from 20 Hz to 60 Hz. So our system will play with subs between 20 and 60 and with the tops between 60 up. Okay, but in this moment, all the energy is concentrated in the center, so it's not a good thing. So just selecting the subs and right-click on the subs, function new curve. In this case, as you can see, I can select the angle of my curve. Let's suppose that we want to open our arc by 90 degrees. And I have to input the distance between the sources, between the subs. So let's suppose center to center, okay? Not side by side. So let's suppose to work with the subs at 2 meters spaced each other, center to center. And this will be the delay setting that will be automatically applied to our subwoofer in real time. So just selecting this function, you will perceive the coverage of the system that will change immediately. Okay? Can you imagine how to do that with a standard system without network control? Is almost impossible. No, it is not impossible, but you need a huge amount of time. So the last thing that we have to do to work with our system, as you can see now, there is this advice, because this system must be synchronized, of course, because we are working offline, but because there is not the real system connected. What is the last thing that we have to do? As you can see here, we see the function, the curving function that we just apply at the subs. And as you can see here we have another two control of the whole subs, because now these subs are assigned at this function, curved function, with these angles, okay? With these angles, with 0 dB of gain in this moment and no delay. But you know that in order to align our subs with our tops, we will need to apply probably some delay. So for this, we will need a measurement tool, RDNet measure, and then according with our measurement, we can apply, for example, 2 meters of delay, and probably reduce the gain by 3 dB if it is necessary, and reverse the polarity, depend on the measurement, okay? We have all the tools we need to manage the system remotely in real time. So in this moment, we can also give the name at this function, curve and alignment, okay? Let's call it just curve and align. And then last things, we can make a global function. So select all, and right click and do a new function, master, which is this, called all system. In this case, I can mute the system, all, okay, tops and subs. I can delay the already configured system, the already aligned system. I can move it back, for example, in theater to align the system to the drum, okay? And also I can change the wall gain of the system accordingly with the level that we set before between tops and subs. This is another gain after everything, okay, that keep all the difference between different levels, alignment, and so on, and managing the global amount of gain and the global amount of delay. This is really a fantastic tool when you are working with several clusters, for example, delay, etc., in order to make alignment and gaining of the clusters. This is something that completely change your life if you are a PA man in terms of time saving and quality of result. Let me zoom in an icon. You can see that here in the icon, here we can see 3 numbers. These 3 numbers means the address of this particular box, okay? 1, 2, 5. The last number, the number 1, means that this box is assigned to the array 1. So this is not the address. The address is the first 2 numbers. The first number is then related to the controller. We are working with 1 controller, so just number 1. But we could work with several controllers, up to 20. So this can be also 2, 5, 10, 15. The second number is the line of the controller used, and the last number is the position of this box in the chain. In this case, number 5, because this box is the box number 5, 1, 2, 3, 4, 5 in the chain. So this is really useful because if I have some problem with this box, for example, no power, the box is off, okay? This icon became blue. So if I see the icon blue, I know that that box, it is not powered up. So, and looking at the address, I can immediately find out for it, okay? Otherwise, if you have a long cluster and you feel something wrong, it is almost impossible to detect by ears where is the problem. In this case, looking at the address, you can immediately go and work in the box that have the problem. Okay, then we have the mute button, the EQ button, as you see before, when we can access all the extended parameters. Then we have the input meter, the gain reduction meter, if it is working, and as you will see, the icon of the speaker that became green, working normally, yellow with soft compression, and red with hard limiting. This means that this box is assigned to a function, okay, our master function, and the other button means that the device is not present because we are working offline. So this is more or less an what can I say? The workflow. Of course, there are several other things that we could do, but I would like to before go and doing some measurement, I would like to show you how to make manually a cardioid preset of subs, how to work with the cardioid preset, doing real measurement. But before, as you know, I would like to show you how to simulate this system with a prediction software using EaseFocus. So, coming back to our venue, you can see the angles that we have here, okay? And the number of modules, 8, and the height of the flybar. We have all the data we need. We have to copy this data in EaseFocus to create the same cluster, okay? So let me open EaseFocus to show you how to simulate this venue with this system. Okay, so our field is, this is our audience area. Okay, the dimension of our audience area is, the depth is 60 meters. And don't care about this. Let's suppose to work with a 30 meter of width. Okay. This is the point where we will place the system. This is the limit of the stage. Okay. But as you remember, we will start with the coverage at 6 meters, not at 0 meter. So let's go in EaseFocus, and in the A position will be 6 meters. This is a space that will be not covered by the main system. Probably it will be covered by a front field, for example. Otherwise, our cluster will become a banana if we want to cover the starting point very, very close to the stage. Doesn't make sense talking about system design, okay? So, add a sound source from the menu Edit, and select the GLL file regarding the HDL30. Okay, click OK. And this is our, for example, left cluster. As you can see, these are the number of modules. We can see 8, and here the angles. Now they are random angles. We have to copy the angles coming from Shape Designer. So do you remember 07, 17, 27, 27, 37, 5, 7. So 07, 17, 27, 27. 07, 17, 27, 27, 37, 5, and 7, if I'm not wrong, the last two angle. Let me see. Yes, 5, 7. Okay, these are the angles. The tilting, very important. The tilting is minus 5.7 degrees. Okay, the global tilting of the cluster. This, okay, minus 5.7 degrees. So let's go here, minus 5.7. No, sorry, minus 57, minus 5.7. Okay, this is the aiming of our cluster. The last thing that we have to do is to go in the RCF Shape Designer again and see the HF correction and the LF correction. The LF correction is the preset 2.2, the brush shaper. So go to the rigging windows and go to filter and select the preset 2.2 for the low frequencies, and then one by one we have to input the HF preset. So let's go here. So 9, 8, 5, 4, 3, 2, 1, 1. 9, 8, 5, 4, 3, 2, 1, 1. This is our left cluster at 7 meter, at 8 meter height. Okay, so copy this cluster and paste and put the right cluster at the same distance, so minus 7 degrees. Okay, so this is the center of the acoustic center of the system, and this is left and right. The work is done, so just pressing show mapping, and this will be the acoustic prediction of the system in the venue. So in this moment we are looking at 50 Hertz, so there is no sound pressure. But if we start moving up, 63, 80, 100, 150, 160, 200, 200, 300, 400, 500, 630, and so on, until, as you can see, this is a quite good simulation. 4,000, 5,000, 6,000, 8,000, 10,000, 12,500, and 16,000, 1 octave. Okay, you can see also a side view of the coverage, but we have other several tools. One very important tool is the distribution. With the distribution, we can see the difference in that frequency range of sound pressure level in the bad case and in the better case. So you can see that we have a delta of plus minus 2.7 dBs in the whole audience area at 10 kilohertz. If we go at 1 kilohertz, for example, we have plus minus 3 dBs, more or less. If we go at 200, we have plus minus 3.4. If we go at 4K, we have plus minus 2.2. So this is a very good simulation. We can see also the broadband amount of energy. In this case, our system will create in this venue an average value of 118 dBs of SPL, plus minus 3.3 dB. Quite good simulation. Very good. Of course, there is the possibility to add other element in the simulation. For example, if I want to add my subs, I can add my sub array according with my synoptic design. As you can see, I am working with 8 subwoofer 9006. So go back in Ease Focus and click Add Sound Source and select Subwoofer Array. Okay, Sub 9006 and click Add. This is my subs array. I have to input the number of boxes, as well as I have to input the coverage angle. Do you remember the curve function? I input 90 degrees and the spacing between them was 2 meters. As you can see, I can see my subs. To see the behavior of the subs in these conditions, I can also turn off my tops and show mapping just for the subs. Let's select also the proper preset, as you can see, and the simulation is quite good. Let's go to see the simulation 1 octave at 40 Hertz, for example. As you can see, this is quite good. Look at the same simulation without the curve. As you can see, we have most of the energy in the center. Can you see? With curving 90 degrees, the energy is more constant. Okay, it's very, very, very good. Now we can turn on our tops, and our system is exactly the system we designed in RDNet. Okay. In order to create a professional report of this, we should do some more some more, let's say, aesthetic things. Let's call this instead of HDL30A1, let's call right. Okay, and then this is the left, and this is our sub array. Then if we go to the file menu, go to the project properties, we can input the project title. Let's suppose Sirius Sound Theater. Author is me, Lucio Boiardi Cerri. The company is RCF SPA. And here we can add some notes, okay? We can also add some listeners in the audience area. These are virtual listeners, okay? And for these listeners, I can see the frequency response. As you can see, this is quite good frequency response of the listeners in the audience area, okay? And this is, let's say, did nothing by my own, okay? Nothing. I just copy in ease focus the data coming from RDNet, from Shape Designer. My only inputs are the starting point of the audience, the ending point of the audience, the height of the flybar, and temperature and humidity. Finish. Then write down or remember this value, copy these values in ease focus, add some information, and then you can go here in the menu file and you can create your report. You can select also the thing of your report, Sirius Sound Theater with the data of today. Let's save it in the desktop, and automatically the ease focus will create a PDF document, this PDF document that I'm showing you. Let's hide the panel in order to, and this is project information, Sirius Sound Theater, today, the author, the company, the temperature, blah, 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 etc., etc. We see some information about the acoustic simulation, a view. We see the sources, HDL30. We see the distribution, the average distribution. We see the global filter flat, because we can also equalize. And then, most important, the sound source left setup. So vertical tilting, pickup point, the 18 AR, okay? And then the angle we have to set among the cabinets with the final tilting of each cabinet. Equalization, same thing for the right, and same for the subs array. The distance, the delays applied for in each subs, and the position of each subs. We have also the audience zone frequency response, and that's it. Of course, you can print this document and you can demonstrate how your system will behave in a certain venue. This is a common workflow in order to work, in order to sell the systems, in order to be sure if your system will work in that particular venue. Because sometimes we need to make some adjustment, we need to add or remove modules, we have to change kind of system. It is not easy, not always easy to find the best way to design a system for a certain venue. Sometimes we have to work, okay? But this was just to give you an idea what is our workflow. This is, let me save this if you need to evaluate offline this job. Let's say Sirius sound theater. Save on the desktop. Okay, so if you are agree, I will take just 5 minutes of break before go online with the system and before come back to RDNet to take some measurements. Okay, so see you in 5 minutes. In the meantime, if you want to write down some questions, of course, I'm here for that. Okay, we are back. So let's go on and let's restart and let's delete our system. So select all and delete all the object, no functions. And let's work as we usually work when we are on the venue. So the system, let's suppose that the system is on, okay, and properly wired. So just press go and automatically RDNet will scan for the connected devices. Oh, here we are. These are the devices now online in real time. We have 2 subs, 9006, and 6 modules, HTL25. Okay. Let me show you the system we are working with. This is the rear view, and this is the front view. As you can see, I use 2 subs, one facing backward and one facing forward in a classic cardioid configuration. And I want to show you how work the preset that usually we select when we push the button cardioid in the subs. Okay, this is the system we are working on in this moment. The system is not flown because today is raining, so we are forced to work in this way, but it is more than enough to demonstrate how is working, how RDNet is working. So select the clusters and assign the clusters to an array. Okay, if you can listen, I am sending the pink noise at the cluster, and this is the cluster setting in this moment, completely flat, and the crossover point is 75 Hz. These are our subs. Okay, so now I want to take some measurement. As you can see in the previous slide, we are working with 2 microphones, one in the back and one in front. The microphone in the input 1 is in front, and the mics in the input 2 of my audio card is in the back, exactly at the same distance between the subs. Okay, 3 meters in front and 3 meters back, in order to demonstrate how work cardioid preset. So go and press the button tool and select measure. The RDNet measurement system will open. As you can see, we are working on a measurement software very similar to the most common measurement software. Here we have some tools to set up the audio card. So let's select the button, this button, to go to the audio settings. And in this moment, we are working with the Dante virtual sound card, because I am connected with a Dante device, converting Dante to analog, because it's more easy for me to do the webinar from my office, working with the system outdoor. Sample rate, we are working at 48 kHz. Fabio, scusa. Sorry, and I'm working at 48 kilohertz. So click OK. And then we have to change, we have to select our reference signal for our measurement. Our reference signal is Dante channel number 3, because my wiring is in this direction. Then I can set up to 4 modules. Okay, so let's enable the first player that is connected in the Dante channel number 1, and let's select also the second player that is connected in the Dante channel number 2. So the microphone in front and the microphone in the rear panel. Okay. So let's go back in my synoptic design, select the subs, and apply, and be sure to work with the proper setting. My subs will work between 20 and 60 Hz. And go back in the measurement system. From here, we can change our view between design, venue, and measurement in this case. Okay, let's work just with the front microphone in this moment. Okay, don't care about the rear microphone, because now I want to measure the cluster and I want to align the subs facing the audience area with the top. So I want to demonstrate how to align the system. Okay, so but let me spend 5 minutes to explain how we are using two signals, not just one, but 2 signals. Let me show you this slide. We are working with dual channel measurement, not single channel measurement, okay? Because using just one channel measurement, we can't detect the distance between the microphone and the source. Instead, if we have a reference signal, which is the same signal that is going in input in the source, that signal is looped back in the audio card, and in this case we can compare the 2 signals and we can detect the distance between the source and the microphone. So detecting the distance, we are detecting the phase, because talking about phase means talking about millisecond, talking about delay, talking about distances, because you know that the sound speed is 344 meters per second. Okay, that means 3 meters and 44 centimeters per millisecond. So in 1 millisecond, 0.344 meters in 1 millisecond. So in 1 millisecond, the sound will travel for 30 centimeters more or less. So talking about time, talking about sound and time, we are talking about distances and phase. And so with the reference signal, we will be able to detect the position of our sources. This is crucial. This is really important to align the systems. Okay. Come back to RDNet. Go in our synoptic design and unmute the top. go to the measurement signal. You can see the impulse response of the system and the frequency response, but the phase makes no sense. Makes no sense because the two signals are not aligned. So with the auto delay finder, calculate delay, automatically the software will calculate the delta delay between the reference signals and the measured signal. That delta delay is the distance between my source and my microphone, okay, plus the buffer size of my audio card. In this case, 21 milliseconds apply, and as you can see, I can read a phase plot with sense, okay? Save this measure. We can also give a proper color and call it tops. Okay, but probably I have a little bit too much low frequencies. So let's go to our synoptic design and open details of our array, go to the best shaper and try to reduce by 3.5 dBs, for example, the low frequencies, and come back to the measurements. As you can see, this is a low shelving in the low frequencies. So let's delete the previous saved measurement and save another one with the new low frequencies response. Sorry, edit measure, and this is our tops. Now go back to the synoptic design, mute the top and unmute just the sub that is facing over the audience area, not the one facing backward. Okay, this is the one facing backward, but let's deal with that guy in after. Now I want to align the subs that is facing forward. Unmute the subs and go to the measurement system. This is the subs, probably a little bit too much gain. So go here, open the detail of these subs, that is this. Keep this open because it's more convenient. I go back to the measurement, keeping this open. Very, very useful. So let's reduce the sub by 6 dBs. That's good. And this is our crossover point. As you can see, in this range, the acoustical crossover is set to 75 Hertz, exactly the frequency range of our tops. Okay, so let's go back to the measure, but you can see that our goal in this moment is to overlap the phase of the subs with the phase of the top in the crossover region. Okay, as you can see, the phase is overlapped just here and not here. So here we will have cancellation. So it does not work. It does not work, definitely not work, because we need to delay the subs in order to overlap the phase as much as possible. So as you can see here, we have a delay. Okay, so let's try to increase the delay. Look at the phase plot that is getting better, but not yet. We have to try to delay too much. As you can see, this is too much phase rotating. It means that probably we have to start again from from scratch and try to reverse the polarity. Now I'm running just to give you an idea of the workflow. Of course, all these things will take one full day of training. Okay, I want just to stimulate in you the curiosity to use this tool and to make to work with the audio to get the best result. So reverse the polarity and try to delay the subs. Okay, seems very good. A little bit more. A little bit more. Okay, here we are. The system is in phase. Okay, so in order to be sure that the system is in phase, let's capture the sub trace and go and unmute the top. Look at the zoom. This is our crossover point working perfectly. This is a very good alignment, okay? A very good alignment. So let me hide our previous measurement. This is our systems. This is the phase, the frequency response of our system, and let me capture the system in phase. System in phase. Okay, this is my system in phase. Look at what happened if I reverse the polarity of the sub. So if I don't care about time alignment, reverse the polarity. Look at the cancellation. We are losing something like 6 dBs. 6 dBs means 2 times the sound pressure level. 6 dBs means 2 times the power of our amplifier. It means that if we are working with an amplifier of 2000 watt, we are using just 700 watt in this case, because of the cancellation due to the fact that we are not in phase in the crossover region. So is definitely very important to deal with phase alignment. Okay, so let's go back with our phase plot with our system in the right alignment position, and then let's go to work with the other guy, with the other sub. But before, so I want to create a cardioid sub configuration using RDNet. So to do that, mute the top, and I want to take, now this guy is aligned with our top. So this is my reference, okay? I want to see how these subs is sounding on the stage, okay? On the stage, using the microphone in the back. So go to the measurement system. Let me unmute this. This is the subs on the back. Okay, let me input the same time delay in order to have 21.1, in order to have the possibility to see a phase plot with sense. And this is my sub on the back. So in order to create a cardioid systems, I have to capture these subs And my goal is to cancel this energy. And what can I do? I can use the other sub. So save this measure and call it sub audience, to indicate that this is the guy that is looking at the audience. Okay. Now, let me delete the, sorry, I delayed. This is the subs looking at the audience. Sub audience. And now I want to use the other guy to cancel this. And as soon as I cancel this, automatically I will zoom the same sub in the audience, because now we are looking at the rear microphones. So go to our synoptic design, mute the subs because the measurement is there and also the phase is there, and unmute the other one, the subs that is facing backward. Open the detailed DSP details of the subs, move these details in somewhere in order to have the possibility to open the measurement and to keep open both. As you can see, we have a lot of energy on the back. Okay, so let's start to read. Our goal is to overlap exactly this and this. Once they are overlapped, the two subs are behaving exactly in the same way. So reduce the gain. First of all, do you remember the polarity of the sub facing forward was reversed? So reverse even this polarity and reduce the gain in order to achieve the same okay, almost. You can see that here we have a little bit of difference in frequency response because one sub is facing backward. Okay, so in order to overlap as much as possible, we can place, for example, a low pass filter in this way, out of band. As you can see, they are quite good matched. Okay, the sound of the subs facing forward now is exactly equal to the sound facing backward from the stage point of view. At this point, we have to deal with the phase. The phase are definitely not equal because we need to delay these subs until we overlap the two phase traces. Okay. Too much. Okay. Here we are. 3.5 meters. As you can see, now the two subs behave exactly in the same way. Okay. Now, if I reverse the polarity of the subs facing backward, you will see a very good cancellation. Invert the polarity and open the other sub. Now we have two subs playing. Let me open also the microphone in front of the system and look at the difference. We are talking about plus 15 dBs in front of the system and minus 9 dBs in between -5, -6, and -9 dBs in the back. We are talking about more than 20 dBs of cancellation. Okay, the stage is completely silent. This is the way of working of cardioid subwoofers. As you can see, you can't manually create your own cardioid setup using RDNet in a very, very easy and simple way. Now both the sub are playing, and this is the result on the stage and in the audience area. Okay, this is one of the things that you can do with RDNet. How can I say? This is amazing. This is amazing because it will allow you to save time. So let's open our top, and this is our wall system, okay, on the audience area, and this is our system on the stage. We have a consistent amount of energy on the stage in this frequency range because the system is on the ground and we are very close to the wall of this building. We are not working with a flow system in a real stage. In a real stage, this plot will be something like that. These are the reflection of the building we are working in. Okay. So anyway, this today we saw some of the RDNet possibilities. There are a lot of. Can you imagine if we are talking about a subarray with several clusters, side fill, delay, etc., etc.? We can work on it in a very, very quick way. Something that is impossible to achieve with a system without network control. Okay. So if there are some questions about it, of course I am here. Otherwise, I again hope to do a full training about these topics live with you, because commonly here in RCF we allow rental companies and sound engineer to become members of the RCF professional team just after a full day training. That is definitely very, very important, because we have to touch this, we have to listen this stage to feel to feel what we are doing. Okay. It's not easy to see in a webinar, but anyway, there are a lot of video tutorials in the website. If you want to go on the website, you can go in the RCF software section, where there is the RDNet, and at the bottom you will see, if you search for RDNet software, at the bottom of the website, there will be a lot of link about RDNet video tutorial, starting from scratch, system design, RDNet measure, connection, subwoofer management, system management, synoptic design, and also there are other video tutorials made by me regarding time alignment, regarding how to read a phase trace. What does it mean, this plot? Okay, because this plot is very easy. This is the frequency response, but this plot regarding the time, okay, and it will take some time to explain in the proper way how to read these plots and how to align the system using the impulse response. But it will take some time, at least one day, better a couple of days. Last thing that I want to show you in this quick webinar is what we do usually presenting a software simulation, because before I show you the ease focus, let's say, output, okay, and this is the ease focus layout, okay, that is the layout of the AFMG software house. I don't like this. So usually when we present a purpose of a system, when we present a proposal of a system, we customize a little bit our way to see and to present our work, our systems with our simulation. So we copy and paste some plots and some simulation from ease focus, and using PowerPoint we work with some images, with some and with this workflow that I'm going to show you. So introduction, we are talking about outdoor theater in Poland, in Cracovia, and usually, first of all, we present the system. So we present the HDL28 in this case with some features and deployment strategies, in this case left and right of the main system. Same things talking about front fill. We are using the TT515A as front fill in this position. Talking about subs, we are using 3 clusters of cardioid subs 9004 AS in an arc. Then array mechanical details coming from ease focus. Everything is coming from ease focus. These are ease focus images, but with some work, with some graphical work done by me. So mechanical details, so angles, height, etc., pickup point, and then simulation. This is a simulation broadband, so 20 Hz to 20 kHz. This is the simulation at 50 Hz, just looking at the sub. Simulation with the subs on the stage. As you can see, our stage is almost clean, and the audience is quite good covered. Simulation and at 250, 1 octave, 1000, 1 octave, 4000, 1 octave, with different view, side view, high view, and distribution graph. We are talking about at 4,000 hertz, a distribution of plus minus 1.5 dB. Very, very nice distribution. At 1 kilohertz, we have a distribution of 2 dBs. And 8,000, 1 octave, 1.5 dBs. Frequency response of the listeners spread in the audience area. Okay, quite good. This is a common plot of frequency response, but as you can see, most of the listeners are more or less in the same frequency response environment. Then we have the bill of quantity. So how many boxes, how many fly bars, cables, and everything you need to set up this, to sell and to set up the system, of course. This is everything you need. And then some accessory, rain covers, front fill, subwoofer, transportation, stacking, and so on. Just the audio cables are not included because RCF does not supply audio cables. And finish with some notes about this particular systems. Temperature, because in Cracovia the temperature in the winter will be very cold, so minus 20 degrees. Sub indication about cardioid. Anyway, we are talking about the ease focus simulation presented in a more professional way, okay? According also with the consultant need, because sometimes the consultant ask for some request in terms of distribution, in terms of sound pressure level, in terms of kind of speakers positions, different positions, because of restriction of some limitation about that particular venue. Anyway, this is more or less all for my presentation today. And if there is some question, of course, I will be with you for some minutes, no problem. Of course, again, in particular this seminar, because the previous two seminars was more or less product presentation. So that, first of all, is not my job. So sorry if it was a little bit boring sometimes, but my job is do the sound engineer, do the PA manager. So my job is the 2-day seminar. But of course, today it was just an overview of this job, an overview of these tools. Again, in order to design properly a system, in order to align properly a system, in order to make the right decision about, for example, delay positioning, about front fill positioning, about where to put the microphone in the time alignment between front fill and main, where to put the microphone to align your subsystem with your top in the front of house position or in another position. There are a lot of topics to go deep in, a lot, okay? And usually my job is to travel everywhere to do seminars about this, and all, together with RCF demo product, because usually during this seminar we have a system flown with some staff on the ground, subs, front field, etc., etc. I place some microphone, I spread some microphone in the venue, and using RDNet, using the RCF tools, I made my seminar, my training with explaining as much as possible what I can do, the RCF idea about sound, the RCF workflow. So I hope that these 3 seminars was useful for you. I really hope that. And thank you, Spyros. Thank you very much. And thank you, everyone. And welcome in the RCF professional team. Very, very warm welcome with us. Thank you very much, Panagiotis. Thank you very much. I hope that it will take place. Even because it means that COVID finally will finish this very bad period. Thank you very much to all, and see you soon. For any questions, write me an email. My email is lucio.boiardiserri@rcf.it. Waiting for your mail if needed. Otherwise, see you soon in Greece. Thank you very much.